we had some on the modulus, etc. So back on page 15, I don't know which ones I gave you, so does anyone need me to do any of the homework from page 15? I know there was a few. Are we okay? And then the transformations one, any questions on any of those? No? Good. Right, we're on to, the conjugate roots theorem is next. Okay? So write it down and I'll explain what it is in a minute. So, thanks. So if z is a root of the equation a times z to the power of n plus b times n to the etc., where a, b, c, d are all real.
Excuse me please, a phone and a set of AirPods have been handed in here to reception and can be claimed here. Also a reminder to students that fashion show tickets are for sale here at reception, and if anybody would like to purchase them they can come to reception now. Thank you.
So this is the conjugate roots theorem, right? It sounds very complicated, but it's, when we see it in practice, it's not too bad at all. Right, okay. I presume you're ready for me? Right, Okay. So, show that minus 2 plus 4i is a root of the equation z squared plus 4z plus 20 equals 0, and write down the second root. Sorry girls, right, any equation, the complex, or the conjugate roots theorem, so if you have an equation z to the power of something, like it could be z cubed, something z cubed, plus something z squared, plus something z plus a number. It could be something z to the power of 5, plus something z to the power of 4, plus something z to the power of 3, plus z plus a number, okay? The power of z's, right, it doesn't matter what the power of the z is, right? What does matter is the number in front of the z's are all real, right? So A, B, C and D are real numbers, right? So A, B, C and D are real numbers, as in they're numbers, they're not imaginary numbers, there's no I in them. So the coefficients of the z's have to be real, right? Okay, they have to be real numbers, okay? Right, and if z is a root, as in if it's a solution, right, if it's one of the answers, then z conjugate is also a root of the equation, right? So what I mean by z is if z is 2 plus I, what's z conjugate? What's z conjugate? We learned it last day. 2 minus I, isn't it? So if 2 plus I is a solution, then 2 minus I is a solution. If 3 minus 4i is a solution, what's another solution? 3 plus 4i. But this only holds true if these coefficients, right, are real. I've seen an exam question where they haven't been real and they ask you why it isn't a root. Okay, so it's the coefficients of the z terms must be real, as in must be a real number. Okay, right, so example 1, we'll do a few examples that make more sense then. Example 1, show that minus 2 plus 4i is a root of the equation z squared plus 4z plus 20, and write down the second root. Okay, so you know if I said, wait, let's see, x squared plus, give me a minute, 6x plus 5 equals 0, and I said show that minus 1 is a root. How would you do it? Right, before we got onto these imaginary complex numbers, etc. You know, if I just said that there's an equation, show that minus 1 is a root, or show that minus 1 is a solution, how would you show me that? Everywhere you see an x, put in a minus 1, yeah? So everywhere you see an x, put in a minus 1, and you'd end up with 0 equals 0, yeah? Same thing here, right? Okay, I got very enthusiastic with that there. My head nearly came off my shoulders, right? So show that minus 2 plus 4i is a root. So here's the equation, z squared plus 4z plus 20, right? So everywhere I see a z, I'm going to put in a minus 2 plus 4i. So it's minus 2 plus 4i to be squared plus 4 times minus 2 plus 4i and plus 20. I'm going to work it all out, and I should end up with 0 equals 0. So if I end up with 0 equals 0, it's a root. It's a solution. It's an answer to that equation. Okay, so squaring the first, which is 4, twice the first by the second is 16i. Square the last is plus 16i squared. Continuing on here, 4 by minus 2 is minus 8, plus 16i plus 20 equals 0. Right, everywhere I see an I squared, I'm going to put in a minus 1. So that would be 16 times minus 1, which would be minus 16 minus 8 plus 16i plus 20. And I'll end up with 0 equals 0. That's a true statement. So that means minus 2 plus 4i is a root. Right? And because the coefficients of the z terms, as in that's 1, which is a real number, that's 4, it's also a real number, though that 20 is a real number, isn't it? Right? Because the coefficients are all real numbers, that means the conjugate roots theorem applies. So if minus 2 plus 4i is a root, what's the other root? Minus 2 minus 4i is also a root. How many roots does this equation have? How many roots, how many solutions does this equation have? 2. It's always the highest power of z. So z to the power of 2 means it's got 2 roots. Z to the power of 17 means it's got 17 roots. Okay, so it's the highest power of z tells you how many roots. So I have that whole equation solved, don't I? Right, there are my 2 roots. Is that okay? So they told me 1, right? And because the coefficients are real, right, that means the conjugate is also a root. You with me? Everyone okay? Example 2. I'm going to tell you the answer. So I'm going to give you the 2 roots this time. So here I gave you the root, one of the roots in the equation, and asked for the other root. Now I'm going to give you the 2 answers, and I'm going to say find the equation. There was a shortcut. Does anyone remember what the shortcut is? You know, it was to form an equation given its roots. It was x squared minus x times the sum of the roots plus the product of the roots. Yeah? Okay, well I do it out the long way and then remind you of the short way. I'll do it out the long way. So look, one of the answers is z was equal to minus 2 plus I. The other answer was z was equal to minus 2 minus I. Yeah? So there's 2 answers. Here's one answer, here's the other answer. Agreed? Right? This was originally z, bring it over, plus 2 minus I equals 0. This was originally z plus 2 plus I equals 0. Agreed? They were originally 2 sets of brackets before you split them up and let them equal to 0. They were originally multiplied and the answer was equal to 0. Okay, and then you need to multiply it. So you need to split up the first bracket, write the second bracket down twice. It just happens to be 3 terms in the first bracket. So it's z times z plus 2 plus I, then the next term plus 2 times second bracket z plus 2 plus I, then it's minus I times z plus 2 plus I equals 0. Agreed? Multiplying out, that's z squared plus 2z plus zi plus 2z plus 4 plus 2I minus zi minus 2I minus I squared equals 0. Tidying it up, I have a z squared term. I just have the one z, I have 2 z terms, 2z and 2z gives me 4z. Then I have plus zi minus zi. I have plus 2I minus 2I. And then I have plus 4 minus 1, agreed? Which would be plus 4 minus 1 is plus 1, so that would be plus 5 equals 0. And that was the original equation, which is what they wanted me to have. Please note the coefficients are real. There's no imaginary numbers in the quadratic, which means the complex conjugate or the conjugate roots theorem applies, right? Okay, which we know it does anyway because they gave me the solutions. Okay, right, that's the long way. Okay, so the short way is we learnt it in the algebra and we remember it very clearly. Right, okay, so the rule is z squared, to form the equation, it's plus z times the sum of the roots sorry, I think it's minus z times the sum of the roots plus the product of the roots. Right, that's not in the log tables, you need to learn it. Is that okay? Right, so filling that in, it's z squared minus z times the sum of the roots. That means add the roots. So one of the roots is minus 2 plus I, and the other root is minus 2 minus I. Then plus the product of the roots, so it's minus 2 plus I multiplied by minus 2 minus I equals 0. So that would be z squared minus z times, putting those together inside, it would be just minus 4. Right, product of the roots over here, you split up the first bracket, write the second bracket down twice, so that would be 4 plus 2i minus 2i minus I squared equals 0. So that would be z squared plus 4z. Here the i's cancel and I have plus 4 minus minus 1, which is plus 5 equals 0, which is the same answer that I just got a minute ago. Okay, so if you don't remember that, you do it out the long way. If you remember that, happy days. Okay, is that right? Are we good? So example 3, you ready? That's very useful though. That is very useful. And you can use it in algebra as well. Right, okay. Right, are we good? Example 3. So I have a z to the power of 3 now. Doesn't matter, z to the power whatever. Right, as long as the coefficients are real, the conjugate roots theorem applies. So as long as the coefficients are real, which they are, right, the conjugate roots theorem still applies. Yes. Yeah. Right, ready? Okay, so show that the minus 2 plus 2i is the root of the equation. How do I do that? Everywhere is e z, what will I put in? Minus 2 plus 2i, isn't it? So here's the equation, 3z plus 4 times z minus 8 equals 0. And then everywhere I see a z, so it's minus 2 plus 2i all to the power of 3 plus 3 times minus 2 plus 2i to be squared plus 4 times minus 2 plus 2i minus 8 equals 0. Okay, there's a bit of work in this, there's a bit of cubing out, isn't there? Okay, so you see this, I'm just going to split this up into minus 2 plus 3i multiplied by minus 2, sorry, plus 2i, isn't it? Why did I change that to a 3? Minus 2 plus 2i all to be squared, right? It'll just make things easier for me because I can square the brackets. So I'm going to square it and then multiply it by a third one. Is that alright? Here I'm going to square the first 4 twice the first by the second, which would be minus 8i, square the last would be plus 4i squared. Okay, here minus 8 plus 8i minus 8 equals 0. Yeah? Then minus 2 plus 2i multiplied by, look at this squared already, don't I? So will I just change that? You know the way when I sort this out, it'll be, that'll become a minus 1. So what will that whole bracket become? Just minus 8i, isn't it? Would you agree? So I know I've just squared that out over there, so I know the answer when you square it is minus 8i. Is that okay? I just used it over here. Are you with me? Right, okay. Then I have minus 8 plus 8i minus 8. So there's a bit of multiplying out here because it's a cubic equation. Multiply out here 16i minus 2 with that 16i. That's minus 16i squared. Right, plus, sorry, minus 24i minus 8 plus 8i minus 8. Remember that's a minus 1. So that would be 16i minus 24i will be minus 8i plus 8i. So all the i's cancel out, and the numbers, that's plus 16 minus 16. So all the numbers cancel out. So that means we end up, sorry, we end up with, we end up with 0 equals 0, which is what I wanted to end up with. So that means minus 2 plus 2i is our root. Part 1. Okay, right. How many roots does this equation have? How many roots does this equation have? 3. So I need to find 3 answers. I have 1. Right, okay. Our conjugate roots theorem says what's another root? Therefore, that minus 2, 3 dots means therefore, by the way. That means therefore, right, okay. So that means minus 2 minus 2i is also a root. Because the coefficients are real, as in these are real numbers, all the numbers in front of the z's are real numbers, right? So the conjugate roots theorem applies. So now I have 2 roots, don't I? So now I have to get the third one, right? So what I need to do is I need to get the quadratic, right? Okay, so that these two make, right? So will I go with z squared minus z times the sum of the roots plus the product of the roots? So that would be the quadratic that those two make, okay? Not the answer yet, okay? So I'm using the shortcut, so z squared minus z times the sum of the roots is minus 2 plus 2i minus 2 minus 2i plus the product of the roots means multiply them. Minus 2 plus 2i multiplied by minus 2 minus 2i. Okay, can I move it up? Is that alright? So z squared minus z times, inside this bracket I end up with a minus 4. Okay, and over here I end up with a, when I multiply out, that's a plus 4i minus 4i minus 4i squared. Replace that I squared with a minus 1. So I end up with z squared plus 4z. It just happens to be the same as the last one. Pity. Right, okay, because it might be... Oh no, it's not. It's not the same as the last one, sure it's not. that becomes a plus 4, doesn't it? So it's plus 8. Yeah, that's quadratic. Have I that right? Please keep an eye on mistakes, because you know there's plenty. Right, okay, are we good? Right, so I have a quadratic, but they wanted me to solve a cubic. What'll I do now? Divide, right? So my original cubic was, where is it? I'll put that back now in a minute. Z cubed plus 3z squared plus 4z minus 8. Okay, sorry, back there. Okay, so I want to divide that by the quadratic I just got, z squared plus 4z plus 8. So I'm going to do my box. You do it whatever way you're comfortable. So that will be a z anyway, and that will be a minus 1. So that will be a minus z squared. This will be plus 4z squared. That's right, because those two diagonals go together. And this one is a minus 4z, and this is a plus 8z. Yeah, so I'm right. So the third factor is up here, see it? Third factor is z minus 1 equals 0. So that means the third solution is z equals 0. Sorry, it doesn't, it's z equals 1 when it comes over. So your three solutions are 1, minus 2 plus 2i, and minus 2 minus 2i. Please note, a cubic equation will always have one real root. Okay, we said that when we were doing algebra. We talked about the roots of a cubic equation, and remember we said a cubic equation, right, if it doesn't cross at all, like so, it has one real root and two imaginary, because it doesn't cross again, remember that, which is what we have here. Okay, so a cubic equation will always have at least one real root. So if you get two imaginary roots, the final one will be real. Do you all hear me? Okay, it's a bit of work in that. Right, there's a lot of work in that. Okay, right, but I'll give you a few of these and see, can you work it out yourselves, and we'll iron out the problems tomorrow. Okay, so page 24 to 25. Let's do numbers 2, 4, 6, 8, 10 and 12.